Hello, everyone. This is David, your host. Welcome to Meanwell Tech Spark. Today, I'm joined again with FAE Harland. Thank you so much for coming back. The VFD was a great Tech Spark, and I'm happy to have you again for our next series.
Hi, David. Hi, everyone.
In this Tech Spark, we'll be going over the ultra-low open frame PCB type power supplies. And in Meanwell's history, for the past 10 years, the EPP and RPS series have sold millions across the world. And within that time, there is a demand of increasing the power density of power supplies, overall, especially for the PCB type. And what we've done is to increase the power density of these open frame power supplies. We've been able to lower that height in the new LOP series. So in this Tech Spark, we'll be going over the LOP in depth to see, what else in addition to that lower profile that we're providing in this new series. So Harlan, could you let us know, the key features about the LOP?
Yeah, sure. LOP stands for low profile, open frame, and with a PCB power supply. Then by having the compact size at 4 inches by 2 inches at the lower power and 5 inches by 3 inches at 500 and 600 LOP, then so we reduce the height on the LOP to provide more saving, provide more space saving for the customer. Then it also has a universal AC input from 80 to 264. So the input voltage from 100 to 240 are fitting in the most countries worldwide. And then so we also have a 10% of the input voltage difference. It is not only to fulfill the test standard of the safety regulation, but also be more feasible to use the LOP. And then, so the LP also is very efficient at transforming the power. So it has up to 94% efficiency. Then by considering the energy waste when using the power supply, then the LP also was developed with the low power consumption, less than 0.5 watt. Then, of course, we are considering some more applications in the field in different areas, and so we develop a wider range output voltage in LOP series.
Wow. So typically when we talk about, reducing the size of something, there's, trade-offs, but it looks like we are gaining a lot of advantages here. And I see, a lot of these features such as the low leakage current and no power consumption, no low power consumption, as things kind of alluding to the safeties as well, right? And I see here that we have a bunch of numbers. Harlan, can you help us translate what those safeties are?
Oh, sure. So the LOP is certified in 4 different standards. So the first one is IEC 62368, which is a safety standards for the audio, video, information, and communication technology equipment. And then it provides guidelines for the design and the evaluation of the safety aspects. So some ITE applications, we have the display screen, and then so telecom or network equipment. So our LOP series can be a good fit in those applications. And moving forward to the medical, so which is 60601, and then so it is a technical standards for the safety and effectiveness of the medical electrical equipment. So we can see some medical device like a body pressure reader, which has a close contact to the patient. Then so we by providing the extremely low volt leakage current at the LOP, then so it's safe to apply the LOP in those applications. And the next one is the industrial, which is so the industry is a 6.0 and then so it basically has the control system and automations of machinery. So our LP is also suitable for the industrial. Then so of course we don't forget the household market.
Yes.
Then so the countertops equipments, cleaning, appliance like the vacuum,
Yes.
and home entertainment device like a TV. Then so our LP is very suitable to power those applications.
Got it. That's right. So given that the LOP, has that means of protection for patients and operators, that's why you can see it now being applicable to use in household and medical applications. And going back to the NGE series last time, I see a common theme here with the new Meanwhile MPIs that we are adding all these certifications, because of all these additional features, such as PFC, which is why we're able to have this industrial application, and for things like ITE for the ATM machine, the same LOP can go in there, as well as in something like a medical application for a centrifuge for DNA replication. And when I was looking into the LOP series in general, kind of studying about that series, I noticed something called OVC. Can you tell us a bit more about what that means? OVC 3, I believe.
Yeah, so the ICE defines the installation categories labels OVC1 to OVC4. Then so OVC stands for the over voltage category related to the power equipment that is connected from well protected isolated supply, such as the computer fed with the DC by a laptop charger, like our adapters.
Yes.
And so the OVC2 includes all the domestic, workshop, and office equipment that is fitted in main plus and is individually protected by a fuse or a circuit breaker.
Okay.
And moving forward to the over voltage category 3 refers to primary to hot wire equipment fitted inside a switch cabinet or this distributions panel, such as the relays, circuit breaker, and a fixed installation power supplies. And then so the last one is category 4.
Yes.
Applies to power utilities equipment connected directly to the incoming supply.
Wow, that's amazing. So I know for the previous series before the LOP, the EPP and the RPS, they were only able to go up to the OVC level 2. But now that we can go into the level 3 category, right, we have increased our range of applications that we can have the LOP go into, given that we can be closer to that transformer. And can you show us a bit, about how that works in terms of the differences between level 2 and level 3 category?
Yeah, so there are more and more demands on the over voltage category 3 from the various applications for instant industrial control and building automation. So for example, some robust controller products to meet the IEC standards needs an additional AC transformer in series between the power grid and the power supply.
Okay.
And then if the power supply itself, like a LOP in the industrial field, meets the over voltage category 3 requirements, then the AC transformer can be removed while the systems still complies with the IEC requirements. So which not only save the space and the weight in the system, but also reduce the overall cost of the production of the products to further increase the competitiveness of the final product.
Wow, so you can kind of think of this as two ways that LOP is reducing its profile, right? One from the physical aspect of it being just more compact. And then secondly, we don't have to worry about this transformer component when we're designing the LOP into an application. Is that right?
Yes. That's good.
Wow, and can you tell us, about some of the other features that we may have with the LOP?
Yeah, so the LP as the next generation's open frame power supply, and so we would also include other features to support it to well power the application. So such as the remote sense, when the voltage passing through the output cables, there's some voltage drop, and then also the voltage at the low at the applications may different than the voltage at the terminal of the power supply. Then if the applications requires the precise output voltage, for example, 48 volt,
Yes.
then also our power supply can sense the differences and then to automatically increase the output voltage at the terminal of the power supply for like a 0.1 or 0.2, then the applications can have exact voltage that it requires. So and the second features is the 150 peak power compatibility.
Another theme I'm seeing with a lot of our new products.
Exactly. And so by providing the peak power compatibility, so it allows the applications at the cold start to draw a higher current than the rated current to prevent the power supply unit from shutting down. So and then the LOP also provides the class 1 or class 2 installations, and then so to provide the feasibility for the user to apply different type input. And then the last one is the external fan supply, and then also we provide the additional power options to drive the fans to cool the LOP cells or cool other components.
Okay, got it. Wow. So in summary, right, we have this remote sense feature that allows the LOP to output the exact voltage regardless of the length or gauge of the wires in between. So it's smarter in that sense. It has this peak power feature as well. That allows it to cover more applications such as motors that have those cold starts.
Yeah.
It has better safety with this class 1 or class 2 installation options, and also just a lot more flexibility for powering things such as external fans when it's in this system.
Yeah,
That's
exactly.
the big thing. And I'm curious to know between the LOP and the other open frame, lower profile units that are in that 2x4 and 3x4 standard, how does it compare to those?
Generally, so the LP has a better is better than the EPP in most specifications. As you can compare the tables of two, then so the LP provides higher power up to 600 watt. Then by at keeping the same dimension size, 4 inches by 2 inches or the 5 inches by 3 inches.
That's right.
And then so the height of the LOP is lower than the EPP. And then so think about it, David. When the power supplies can generate more power, and then in a lower size, that's a pretty interesting.
And then one key takeaway as well, regarding the height of it, for the folks, that are, always on the phone talking about, what we recommend for a meanwhile power supply, for the LOP 200 and 300, we're actually able to get that height to an exact 1 inch. So it's very slim.
Yeah, exactly. And then so on the other hand, the operational temperature of the LOP is also better than the EVP. So the LOP can start up at the -40. So by giving that advantage, then so the LP can be used in some harsh environments or some high altitudes environments.
Wow, so less than or lower by 10 degrees on the cold and higher on 10 degrees on the hot side. So that also enables us to go into more applications, where maybe previously with the EPP or RPS, they may be limited from those.
Yeah.
And then also, I see that we covered, some of these before. Well, one of the new ones I wanted to highlight in terms of the blue differences between the LOP and the previous series is also the safety. I see RCM and CCC. What are those additions?
So the CCC is the safety mask applied in China, and then the RCM is the safety mask in Australia or New Zealand. So we also make the LOP satisfied with more country and then to promoting these new generations into different countries.
Got it, got it. And I think the last one I want to highlight between the differences here is the additional voltages that we have available. I believe, back in the day with the EPP and the RPS, you would need to call in or email us, to do a modification for these specific voltages. But now in the standard model of the LOP, you can get 18 volts, 36, 54. Can you tell us about why we decided to make these, part of the standard family?
Oh, that's a great question, David. Because by looking at the market's needs and so the high for example, so many rechargeable battery such as those used in the portable power tools, the power drill or others applications operates around 18 volt. Then the LODs with the 18 to output the 18 volts can be supplied those to application to charge the battery. And then you also had the LP also has the 36 volt for those motors application, and then as you can see in the pictures, and then also we can use the LP to power the VFD power supply and to drive the motor. There is David.
We have an example here.
Yeah, exactly.
Can you walk us through what we're looking at here?
Yeah, so this is the VLDC motor, and then we of course use the VFD to drive this motor. And then so when evaluating the power supply to drive this type of DC type VFD, and then so by considering the 150 peak power capability, and then so the LP may be a good fit to power the VFD. And then so by giving the compact size and the slim fit, then so if we stack up two together, you see how small they are.
Yeah, very portable. Wow.
Yeah.
Look at that. This is the LOP 600 over here, is that right?
Yeah, so this LP 636 to provide the 36 voltage to the VFD, and is because the motor is a 36 volt class motor. And so the need is for the motor is using the two BLDC motor in parallel, and then so we can use only single LOP 600 to drive these two motors.
Got it. So I see why there's a need, for adding that 36 volt. And then for the 54, you noted here an example of PoE. Is that right?
That's correct. So PoE stands for the power over Ethernet. So the high voltage are more efficient for the power transmission over the longer distance. By using a higher voltage like a 54, the PoE lasts up to a maximum distance of 100 meters. Then without a significant power loss, and it can drive the power over the Ethernet cable. So the PoE is a new is the technology used to transmit the power and the data over the Ethernet cable. So typically to power the device like IP cameras, wireless access points, and VoIP phones. So the 54 within the safety limits defined by the IEEE or the IECs is safe for using in the PoE applications without posing significant electrical haste to the user. And then so our LP that outputs 54 is really a good fit in those PoE application.
Wow, so I'm glad to see that the LOP is really, going all the way when they want to, increase the product offerings, at least within the standard model version. So given that we've gone through a lot of features already, could you give us maybe a brief summary on what are the key things to remember about the LOP series as a
Yeah.
whole?
Generally speaking, so of course, by keeping the same dimensional size of the open frame power supply, and then also so the LPA has lower high standard EPP.
Yeah.
So when you look at the comparisons, David, so the LP at the size of LP 600 at the 5 inches by 3 inches,
Mhm.
comparing to the EPP 500 at the same size, it actually power more, but
Yes.
at a lower height.
Wow.
Yeah, that's a very attractive. And then also, of course, because it has a high efficiency
Mhm.
features, so the power density is better. So the operational temperature, the peak powers capability as we talked about, and then also the low leakage current and the better isolation.
Wow, and that isolation, again, going back to increasing the certifications into the medical and household applications. So we have that low profile, better performance. You'd think that when we, do these changes to anything, for example, like, when the Apple MacBooks, got slimmer and slimmer into the MacBook Air, those prices went up. But for our LOP, the last takeaway I want to mention is the lower cost as well. So in addition to having that lower profile to be placed into more applications as well as better performance, covering a larger range of things that it can work into, the LOP is also cheaper than the other previous series, EPP, RPS, roughly 10%. So the key takeaways, are in the low profile, better performance, and lower cost. And I know from our TechSpark feedback, we hear a lot of people asking about applications. Can you give us some examples on how the LOP can be used out
Okay.
in the field?
Yeah, so I actually bring 4 examples applications, and so the first thing is of course is IPE 62668 certified, and then so some security system monitoring systems or display screen can be powered by our LOP. And then, given the LP is certified in multiple standards, so then the same security system in a household in home can also use our LP because it also certified household standards.
Yes.
And then, so moving forward to the household application, as we talk about the security system, and also the carbon filter heating to provide the heat used in external enclosure with the control board. Then the solution is to so this application is used to power the carbon filter heatings, and then so which is efficiently convert the power to heat. And then by considering is friendly design and need to has a compact size, so our LP is a great fit in this application.
And I see an example here that the power supply is in the corner, then, right at our feet, away from the consumer. But, can the LP be also used in applications where, someone needs to touch, the device, that has the LP inside of it?
All right, so and then so because this type of application has a close contact to the user, and then so as a LP can have a great features at the extremely low leakage current, and then also it is very safe to install the LP in those applications. And on the other hand, the LP is also comply with the 60601 medicals standards. So this application can also be used in a hospital. Yeah, instead of only in the only at home.
Yeah, what are some medical applications we can look at here?
The other medical applications is like the medical monitoring device. So such as the blood pressure reader, and then the blood analysis, and the heart rate monitor. So our LOP can power those device by given its medical certified.
Yeah, because when you are in those hospital rooms, right, the real estate in there is very crucial to make sure they have all the necessary devices in there. So something like a LOP can fit nicely into a portable, heart rate monitor system that you can wheel around. And then I think we have one more application to look into, the industrial side. Is that right?
Yeah, exactly. So the LP can also power those data center cooling system. And then as Meanwhile has been developing the a full power solutions to the customer to reduce the sourcing time and the cost and the energy.
Yeah.
So those cooling systems built with fans can be powered by our VFD, and then plus the AC to DC power supply. And then so if in some applications and which has a limitation of spacing, so our VFD and the LOP that are in a very complex size are very suitable to install, and then so to eliminate the concern of the users thinking about, how would the power supplies install, and then would they fit in the small space. And then of course the LOPs also meet the industrial safety standards. So there's no concerns to worry about whether it's complying to those systems.
So things like the PFC functionality of all of the LOPs fits well in these industrial situations.
Yes.
Okay, and then before we move on to the next slide, I just wanted to kind of recap the LOP in terms of the things to remember about it. We have that price difference between its comparison to the other series between that 200 and 600 power range, right? Around 10% different. We have that lower profile for all of them as well, the 200 to 300, inch height. And then 300 to 600 are smaller than the other EPP and RPS comparisons. And then the better performance, right? So we get that low leakage current, we get that PSC functionality, no load consumption, and even that wide range of voltages, right? From 18 to 54. Is that about right?
Yeah, exactly. So David, I can discover more features and advantages of LOP for you, as long as you pay more orders for us.
Oh my goodness. Okay. And then I'd like to end on where we can find help. You mentioned, Harlan, that yourself is available, but also we have Brian Liu that you can reach out to, Kareem, and Harlan himself. Also to anyone on the sales side, for your distributor account manager, feel free to reach out to us as well for any help. And then I also want to take this time to announce the next TechSpark coming up. It will be with Hong and Kareem, and they will be scheduled to talk about our new LED drivers. And I heard it's going to be something about Class P.
I don't want to miss that.
Yeah, that sounds great. Alrighty, thank you everyone. This is our Meanwhile TechSpark.
Okay, thank you everyone. See you next time.